All right, so on this episode of Mathematics, we're going to talk about and cover the concept of standard form. Standard form is the format of ax plus by is equal to c. Now, frequently linear equations are written in standard form. Of course, they're also written in slope-intercept form. Slope-intercept form and standard are equivalent statements. I will do a separate video that converting just the standard form into slope-intercept. A little bit later on. All right, so we are going to, a lot of times in mathematics and especially in algebra, we need to convert standard form to slope-intercept form. Well, you might ask yourself, well, why would we have it in standard form anyways? There's a lot of situations where you're in standard form, real life situations, you have two different variables and values. You have apples and oranges essentially. You have so many apples, so many oranges, and let's say they cost something and they're equal to something, an amount, you're buying something. So there are all types of situations in real life where you're going to be dealing with equations that aren't going to necessarily be in slope-intercept form, they're going to be in standard. So we can do a lot of things with, once we convert them into slope-intercept form. The reason that we want to convert them into slope-intercept form is because there's a lot of new things that we can identify. When it's in slope-intercept form, y is equal to mx plus b, okay, we can easily identify the y-intercept. That's the coordinate point when x is 0, and then the b value is that y value, okay? That's where it's intersecting, like a road intersection. That's where it's intersecting the y-axis. We can also identify our slope. So that's another really important concept, is that we are identifying our slope, which is the rise over the run. So we can easily, if it's in slope-intercept form, we can easily look at those things. And there's certain situations where we might want to know that information. And right now we're looking at it just straight algebraically. But later on we can apply that to real life situations. All right, so we're going to take each of these equations and we're going to put it in slope-intercept form. And then we're also going to identify the slope and the y-intercept. All right. Now, the slope-intercept form is y is equal to mx plus b, again. Right now, in order to put this in slope-intercept form, my slope-intercept form says y equals. All right, so that means that I want to get the y value by itself. Okay, well, there's no coefficient with the y, but the 2x is in the way. So I need to move that 2x over with the 3. In order to move it with the 3, we're moving it across this equal sign. In order to move it across the equal sign, I have to do the opposite operation. And since it's a positive 2x, I'm going to subtract 2x. Okay? So I've subtracted it. Now that leaves me y is equal to negative 2x. And then since there's no sign in front of the 3, it's going to be considered 3, positive 3. Okay, well now if we look at that and compare that to our standard form or slope-intercept form, I want to ask myself, am I done? How do I know I'm done? Okay, if you notice, the 3 is in the position of the b, so the 3 is our y-intercept, so I can write our b, that's going to be equal to positive 3. Okay, the negative 2, the coefficient with x, is in the position of m. All right, that's our slope. Our m is going to be negative 2. Okay, now everything else, if we notice, the x is in the position of the x, and the y is in the position of the y. So I know I'm done. I've answered my question. It's in slope-intercept form, and I've answered the additional information of my y-intercept and my slope. All right, let's go ahead and do another question. We're going to look at number 2. All right, I'm going to do the same thing. So I want to isolate the y. Okay, the 4x, I'm going to move that first. Okay, so it's positive 4x, so I'm going to subtract 4x from both sides. That cancels. That leaves me with 5y is equal to negative 4x minus 30. Well, then y isn't by itself. The 5 is in the way. It's being multiplied by y, so I'm going to divide 5y by 5, the coefficient. Now, the rule with equations is I must do it to basically every term that's in our equation. This y cancels out. That leaves me with y is equal to negative 4/5 x minus 6. Okay, now that means my slope is going to be the coefficient with x. So that's going to be m is equal to negative 4/5. And my y-intercept, that's going to be that's going to be that constant number, that number that doesn't have a variable with it. So our b is going to be negative 6. So I am done. Now there is a side comment that I want to make here. Negative 4/5 x. Negative 4/5 x is equivalent to saying negative 4x over 5. These are equivalent statements. When that x is in that position up here on the side, it's the same thing as being in the top of our fraction. Okay, so either one of these are equivalent statements. Now, as I said, we can say that the x is either to the side or on top, because basically it is on the top. But we cannot say it like negative 4/5 times the value of x. We can't put that x in the bottom with the 5. That completely changes our answer. Think about the fact that if x was equal to 2, that would, or let's say x is equal to 5. If x was equal to 5, both of these answers would give me negative 4. But if x was 5, this answer would give me negative 4/25. Okay? So as you can see, that would give you very different answers in terms of what we're looking for. So it's definitely not an equivalent statement. So be very careful on that concept. Okay, I want to go over here and I'm going to look at number 3. Okay, so we're going to move the x over. So we're going to move the x over with the 12. So we're going to subtract x from both sides. That leaves me with negative 3y is equal to negative x plus 12. We're going to divide by negative 3. Divide by negative 3. Okay, here's where your rules need to come into play. As a side concept, I'm going to write it up here just so I have room. When you're dividing numbers, it's just like multiplications. We know that a negative times a negative will give you a positive number. A positive times a negative will give you a negative number, okay? And a positive times a positive is a positive, okay? Well, those same rules apply with division. If I take a negative and I'm dividing by a negative, that's going to give me a positive. If I'm taking a positive and dividing it by a negative, that's going to give me a negative. And a negative divided by a positive, that's also going to give me a negative. All right? So on this section where it's negative x divided by negative 3, that's going to give me positive x over 3. And then positive 12 divided by negative 3 is going to give me negative 4. Okay, it's in slope-intercept form. Now, I need to identify my slope. My slope is the coefficient with x. But wait, I don't see a coefficient with x there. There is, but it's what we call invisible math. There's an imaginary 1 in front of the x. So our slope is going to be 1 over 3. Do not give me x over 3. X over 3 is not the answer. Okay, and our b, of course, is going to be still the negative 4. So we have finished and answered this question. Alrighty, I'm going to do some more example problems on the next video. I would recommend that you pause this, try to do 4, 5, and 6 on your own, and then start on the next video and see if you got them.